Hello everyone, welcome back. So we're going to start 2.5, the discriminant. So what do we call discriminant? Before we have already learned when the equation cannot be factorized, how could we solve the equation? We use a formula helped us to solve the equation. What's the formula? X equals negative b plus or minus square root b squared minus 4ac over 2a. So inside the square root b squared minus 4ac, we call delta. So this is we call discriminant. So what does it help us in solving the equation? So we have some conclusions you need to know. So when b squared minus 4ac is greater than 0, then fx has two distinct real roots. So if it's 0, then one repeated root. So if delta less than 0, so there's no real roots, but there's solutions. The solutions contains complex number, not real roots. All right. So let's look at the curve so that's going to help us. So for the standard form for the quadratic equation, fx equals ax squared plus bx plus c. So when a is greater than 0, the parabola is like this shape. But how does it locate in the system, the coordinate system? So when a is greater than 0, also you have the discriminant greater than 0. So there are two roots. So it could be like this way or like this way, like this way. All right. So if a greater than 0, so the discriminant equals 0. So there is only one root which intersects with x-axis. All right, so if b squared minus 4ac is less than 0, so there is no real roots, it's going to be like this. There's no intersection point with x-axis. So if a is less than 0, so you have b squared minus 4ac greater than 0, which means you have two intersection points on the curve so that you have like this shape. So if you have b squared minus 4ac equals 0, so there is only one intersection point with x-axis. If you have discriminant less than 0, so there is no real roots, which curve is going to like this. All right. Let's look at example 13. So question. Find the values of k for which fx equals x squared plus kx minus 9 has equal roots. So what does that mean? So they are equal roots means the discriminant b squared minus 4ac equals 0. So let's take the function b squared minus 4ac equals 0, then k equals 36. We have k equals positive or negative 6. This is the answer. So let's look at example 14. So find the range of values of k for which x squared plus 4x plus k. So it's going to have two distinct real solutions, which means the discriminant b squared minus 4ac greater than 0. So we have the function 16 minus 4k greater than 0. So try to solve the inequalities. We could have 16 greater than 4k, then k less than 4. This is the final answer. All right. So let's move to the exercises 2G. You could pause the video and try to solve them all. If you have the questions, you could leave your comments. And if I already finished it, you can check the answers at the end of the book. There are a section called the answers. Okay, I'm going to show you where it is. You can go to the answers and try to find the exercises, the number, and check your answers Alright, with the standard answers in the book. If you get it wrong, just think about it and try to solve it. If you couldn't, just leave your comments below the video. I'm going to explain it. Okay, so this is the end of 2.5. So for the next session, we're going to do 2.6, modeling with quadratics, which is we use quadratic equations to solve the real problems. Okay, all right. So hopefully you will enjoy the video session. See you next time.